Technologic, technologic, technologic.
Thank you and welcome to another edition of our tech series where we talk about the geeky stuff at YEO, the stuff that goes unheard of and behind the scenes stuff that we feel is very, very important to the smooth running of any project. And today I have here with me Rob Potton, who is Staircase Wizard. We're doing another staircase here today, which is a collaboration with Watershed Developments, who have designed this. They have done all the design concept of this, and we are tasked with the task of making it a makeable thing and delivering it on site. So, Rob, hello.
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 Lovely model work here, Rob, by the looks of things again. Let's start again by going, right, what is your first consideration when doing a project like this?
Well, with this particular staircase, we were given a design by the architects, as you said, and the first thing I did is obviously have a look at the concept that they've given us to identify, I think the key challenges. Obviously, straight away with this one, there's a curved wall, which I kind of focused on as an item that could be challenging to incorporate a staircase into, and also structural items again. Understanding what the structural items on the site will be, and obviously how our staircase ties into the site architecture and structure. So again, those were the first things that I kind of focused in on with this particular design.
So
the actual, yeah.
Sorry, mate.
That's right. I said the actual concept itself was quite simple. It's got central stringer and it's got open riser treads. And this kind of balustrade design. There was nothing within the actual staircase components that was particularly kind of concern early on. As I say, so I focused on the structural integration between the staircase and site first.
I think one of the key things, when we saw this come through, is that it's a lovely design. The first thing that cropped up was, are those spindles curved or straight? They are curved, and how we were going to go about that. Obviously, we've got some curved handrail details going on. Structurally, this one's quite a simple one, Rob. That middle stringer hooks on the landing and on the steelwork up on the first floor.
Yeah, so again, I've got a version of the model that just shows the structural items. So what we have on site is this I-beam here. And then we have designed this bracket, this bespoke bracket, which the laminated ply stringer, which within its own right is structural, will hook onto. So we've got the main stringer hooking onto the landing steel, and then we have the this yellow is actually concrete on site, block and beam. We have the main stringer hooking over that site concrete on this section here.
Yeah, and then on the stringers on the wall, what we got there, like a metal bracket that fixes the bolts to the wall.
So yeah, we've got these. So because this wall is block and it's being hard rendered on site, we've decided that we don't need to integrate, an entire steel stringer to provide the structural support on this. So we have these L brackets here that are fixed directly to the block work through the render on site, and they fix to the ply stringer that we are fitting and making on the other side, and it has this steel plate in between that provides the support for the tread. So quite a simple concept here of just having this bracket that fixes, to the finish each side, rather than having to integrate something earlier and then conceal it.
Lovely.
So what I will do very quickly is if I just do a very quick section through. You'll just see how the brackets integrate. So you can see here, nice. You've got the bracket here, and our stringer is going to hook onto that, again with tolerance. So the bracket's being fitted to something on site that may not be absolutely accurate. that tolerance gives us the ability to pack the stringer when we fit it exactly square and exactly the right position. And the same at the bottom. We have this bracket here that fixes over the concrete on site, and then our staircase stringer essentially sits on top of that. And it's designed so the stringer can be fitted bottom first, and then so kind of bottom and then drop the top down.
Yeah.
So that's how it's designed to be fitted.
How does that bottom bracket work, mate? Is there a bit that's rebaited up into the, or grooved out into the stringer?
So at the bottom here,
yeah.
we have a handrail that conceals. I can show you. So this bracket is rebaited into the stringer, and then when we fit the handrail, you can see. Sorry, I lost it then. You can see at the bottom here, it then covers that fitting.
That slots in there, and then we bolt through.
So that slots in and completely covers that bracket that's fitted in behind.
Lovely work.
Yeah,
that looks sweet. Cool. Talk to me about the spindles and the handrail.
Yeah.
We're going to the spindles at the top, on the top landing bit. We're going to rebate them into the flooring. Is that right, or groove them out into the flooring?
Yeah. So the flooring on the first floor landing is solid oak flooring. So what we're going to do is we're going to actually cut pockets into that flooring, into which the spindles will slot. They'll sit
was the word
directly down into the flooring.
That was the word I was looking for. Rebates, no. Tenons, mortises. That was the one I was looking. Go on.
So yeah, so that essentially means you will have no break in flooring right up to the edge of that. Essentially up to the edge of this landing, which will look really good because the spindles will just be sitting directly into the timber flooring, which will look really nice. And essentially we're doing the same at the top with the handrail. So the handrail will be machined with mortises, and the spindles will slot into that.
Yeah.
All with quite a high amount of precision, because it's really important that these spindles sit tight to each other to force them into that curve. Now, originally we considered making these spindles flat and kind of forcing them into the curve as we installed them, but we very quickly realised that wasn't going to be feasible. You know, it's just too much of an ask on site and of the material. So what we've done and what we've investigated and also produced a sample of is a balustrade section where we've steam bent the spindles. So the nice thing about doing a steam bent process is you are using solid oak and you maintain that look, that visual of using solid oak, rather than another way you can do it, which is to layer up very thin layers of wood and form it into a curve. But when you do that, you do lose that appearance of it being solid timber. Yeah. So by doing it this way, and because it's such a shallow curve, steam bending has proven a really nice way of getting that shape and maintaining that look.
I'm going to try and insert a video here of the sample that we've created for site that's been signed off at this stage. This project is about to go to manufacture. Another one that I'm quite excited to see how it goes and get it on site. The steam bending of the spindles has been good fun, something that we've not done a lot of, but we've done a lot of testing, and the sample has been a great way for us to discover the exact sort of construction and the way we're going to go about making this staircase. And the handrail, Rob, we've got a custom handrail detail, sort of super sort of small as possible. How does that, can you show me what have we proposed how that's going to intersect into the wall there? Have we got that drawn up?
So the plan is this handrail will be made up in sections. Obviously it's got straight sections, and then it's got these compound curved easings. We'll have them made by an outside contractor using a 5-axis CNC. It's a very good way of getting a highly accurate item. And what's nice is it will reproduce exactly what we've modeled in 3D. So that is how this section works. And where it meets the wall, we're proposing to have a shadow gap detail. Yeah. So what we'll do is we'll have a bracket that is fitted to the wall on site. It'll probably have some form of plate or spigot that then the handrail sits over or is inserted onto, with the piece here this block as just a decorative item to cover that bracket.
Mm-hmm.
And that makes the end of that handrail structural, with it being tied to the site wall. It can't move, and that's really important with the overall design of this handrail, because you don't have a large newel post, which is what you traditionally have, where the handrail turns corners. You need a means of securing it to the wall here and also at the bottom, and we've done that obviously in both cases, so the handrail can't move in either plane. And as I say at the bottom, the way that we've dealt with this handrail and how we're going to make it structural is we have, let's try and get a better view of it. So the handrail itself actually drops and sits into the main stringer. So again, it's cut tight to fit, and it will be bolted through the face of it into that main stringer, and then have cover caps. So you can't see the bolts once it's installed. And that way, that bottom section and that top, there's absolutely no way it can move. And one thing that the spindles do by being curved, it puts the whole thing into tension in this plane and this plane. So once that handrail was glued up, and this is what we discovered with the sample, is once the spindles were glued up in pairs and kind of in their runs, the whole thing was very, very strong. That way it didn't move at all.
Yeah.
Which again, added to the structural fixings we're going to add on site, means that handrail will be absolutely bomb-proof.
Beauty. Rob.
Which for such a small section of handrail, was really important. It's quite dainty. It hasn't got any large structural items that are visible.
Yeah.
And that was the whole point with it.
Flooring. The flooring
Yes.
on this one is Dinison oak, isn't it? White oak, which we're going to use down on any of the steps, the tread boxes, the lower section, and then we're going to finish any other work around it, handrail, spindle, stringer, in the same finish.
Correct. Yeah. So the main landing flooring, which is being fitted by the site contractors, is in Dinison. We're using that same flooring for these sets of treads and rise, these tread boxes here, and the lower section is also being clad in the same material. So the idea being that everything that's timber in that area is exactly the same finish, grain, colour, which will look really nice. Against the kind of white rendered everywhere else.
Yeah. Rob, can you show me the construction of the top tread boxes, please, buddy?
Yep.
So we're making these out of the flooring?
Correct. So the upper tread boxes are being made out of the flooring, and will be mited. So the flooring will be mited around to make the top and the fronts and backs look seamless, and it will have a panel that's sat in the bottom, which is separate, which means we can fit these from above, screw through into the tread box, and then put that cover panel on afterwards. Yeah. So again, once it's fitted, it should look, as close to a solid piece of oak, as you can get.
Yeah, and that access from below, mate, sort of gives us leeway to pack the tread boxes to level and just make sure that we've got access for future stuff and fixes.
It's just rather than relying on, if you didn't have access through the bottom, you'd be relying on kind of a glue joint only. You'd have to basically bond the box in place because you'd have no access to get a mechanical fixing in. Yeah. So by having that bottom panel removable, it allows you to get in and actually put mechanical fixings into the tread itself, which is always preferable if you can. It will be bonded as well to stop it from kind of creaking and moving. Yeah. But yeah, definitely the case.
Lovely. Rob, is there anything on this? What were your, were there any other challenges? I saw how you were drawing up those spindles and that handrail, and it didn't look easy.
Yeah, I think one of the harder things was working out it's really around this curve here. The best kind of I don't want to say compromise, but there's always a balancing act between form and kind of function, and getting the spindles to kind of behave nicely around that curve, was quite challenging. As you can see, where these spindles drop down onto this for the first time, it's still on the curve. So that whole area was quite difficult to resolve and kind of just get looking nice. But we've got there.
No, it's top, mate. Very, very nice. And I think that's going to be that there will be the most challenging bit in the manufacture as well.
Yeah,
definitely. Okay, Rob, lovely. Thank you very much, mate. Top work as always. Another brilliant model from our staircase wizard, Rob. And thank you all very much for watching. We'll be back with another one at some point. All the best. Cheers.
Technologic.